Okay, hello everyone. Good afternoon, good evening. Welcome to this Python class. So before we start, I can see that, okay, am I audible everyone? First of all, someone just give a thumbs up or indicate in the chat. Yeah, okay. Great. So as usual, we'll be doing some problem solving in this session. It's a live interactive session. But before we start, I can see that there's a question in the chat. So Veena has asked some question on mail. So maybe we can look at that first before we go to the class proper. So I think I missed this question. So I'm just looking. So I think this is the question that you had sent. I somehow missed this mail. Sorry about that. So this is okay. So apparently Veena has a doubt in this question. Let's see the code matrix. Okay. So first let's try running this code and see what happens. And then we can try to see if we can understand what's happening. And then we'll look at Veena's doubt. So, okay. Sorry. Okay. So this is the code, and you can see that after running the code, we get the answer to be 99, 99, 99 is attached to all of the matrices, right? So what is the question actually? Okay, fine. So why is the question, if I understand correctly, is if I just print matrix of 0, then it just gives me the first element. But for some reason, when I do this, it assigns it to all three of the elements at once. That's your doubt, right? Why is all three of them getting the same value? Yeah, okay. Huh. That's interesting. So let's just see if this works for all of them, first of all. What did I do? Oh, sorry. Sorry. I just meant to do this. I now print matrix. Huh. So whenever I'm putting for one of the elements, it goes to all the elements. Okay, 1 of 1 is equal to. Okay. So I think this is my guess. I'm also not very sure why this is. I think this is because the matrix was made of a row. The row was, and the row has all the same elements, right? So I think it's because it's just three copies of the same object, which means that we are just adding copies of the same memory location, right? So row, whenever I have a variable, for example, row points to a particular memory location, correct? So in this matrix, I generally have the same memory location repeated thrice. That's only the matrix, right? I'm not having row 1, row 2, row 3. I'm actually having row. So if you imagine, they're all pointing to the same memory location. All three rows of the matrix are calling the same variable, which means they're all pointing to the same memory location. That's why when I modify one row, all the rows get modified in the same way. Because what the computer is doing is it's actually going and checking where the matrix row is and it's modifying that. And that I think is pointing to a particular memory location, and that's why this is happening. So to see if this is correct, let's do it in another way. Okay. Let me clear. Okay. Let me exit first and clear. Okay. So let's see if my hypothesis is correct. This is my hypothesis, right? So let's make another matrix. Now let's do row of 0 into 3 as they did. Let's do row 1 of 0 into 3. Okay. So I'm now having two different variables, right? So now instead of doing it like this, what I'm going to say is I'm going to say matrix is some empty list. And then first I'll append row. Then I'll append row 1. Okay. So now let's try doing. Now let's try appending 99. Sorry, not append. Matrix of 0 of 0 is equal to 19, right? So now you can see that because both the rows had different row, right? They had different variables, which means each row is pointing to a different memory location. If I change the first column, first element, it is only changing that element. And if you want to be sure that this is actually what's happening, let me do one more thing. Let me add one more row to the matrix, which is now by row. So now if I print the matrix 990000. So these two have the same memory location in the computer. So now let's try changing one of them. If what I think is correct, the other one should also change. The first and third row should change in the same way. So I'm just going to change the second element to say 50. Now if I call matrix, so what I said is correct, right? So now you can see that the first and third row change in the same way. The second row is unaffected because again, this is not made from the same memory location. It's made in a different memory location. But whichever rows are made in the same memory location are modified in the same way. So this is what is happening. Oh, okay. You can't see the screen. Oh, okay. My bad. Sorry. Okay. I had been showing everything. Okay. I'm so sorry, guys. So let me just show you my working. Okay. Can you see my screen now? Okay, great. So what I did is here, can you see row, instead of making all three with row, I'll just explain what I did. So here you can see row is there. I made another variable called row 1. Okay. Instead of now appending row to all three of the rows of the matrix, I'm first appending row and row 1. Okay. So you can see that now the matrix is 0000000 like before, but this is made of variable row and this is made of variable row 1. So when I'm changing this row, only this row gets affected. And if you want to check if this is actually what is happening, I'm going to make another copy of row and have it as the third row of the matrix. So now you can see 990000009900. And in this case, if I change any element of the first row, that immediately changes the element of the third row as well, because both of these are made of the same variable, whereas this is made of some other variable called row 1. That's why when I change the element in the first row, the third row is affected, but the second row is not affected because it points to a different memory location. Is this clear, everybody? So point is that every variable, when you define a variable, it's always associated with a memory location. Okay, and it's actually, variable is nothing but a container, right? So it points to a particular memory location of the program. And whenever you change something in that memory location, wherever that variable is used, it's changed. And that's what we are seeing here. And that you can actually see when I use row and row 1, right? Because now you can see that the row which is, the row of the matrix which is given by row 1 is actually not affected by any of these changes. So this is the idea. Okay, did you get it? So the question was that even though we are putting matrix of 0 to 99, all the rows were becoming 99. All the first elements were becoming 99, even though I'm not specifying as 1 comma 0 is equal to 99, 2 comma 0 is equal to 99. The reason is because the matrix is made of three copies of the same variable. So whenever I'm changing any element of of the matrix, I'm actually changing that variable, and that variable is in a particular memory location. So that's why whenever I change it, immediately all copies of it are affected. And the way to verify this is, now I made a matrix made of two different variables, row and row one. And you can see that whatever I did in row is only row is affecting only the rows which are given by the variable row, whereas the row which is given by the variable row one is not affected. So that is the idea. Okay, is this clear to everyone? Okay. Okay, great. So you got it right. So this is the way that you test things in computer programming, is that you can do something and then you can check if it is correct. You just make a variable and then check if that is going along with your thinking. So that's exactly what I did here. I had a guess of what was happening. So I did another case and then I verified if my thinking was correct. Okay. So this is how you think about these things. So you always have to have this image of like variables are associated with memory locations. Whenever I call a variable in a program, and that's just a shortcut for calling that memory location. Okay. So that is how you think about it. Okay, fine. So now let's move to our actual discussion of today. So welcome again to the problem solving session of week. So we are in week 5. So you know the deal by now. We are going to be solving problems together, and this is a forum for you to clear your doubts and other things, just like how Veena has cleared her doubt. And if you do it in the class like this, it can benefit everyone also. So I suggest that you guys can always, yeah, you can always mail me. I try to reply to my mails, but in case I miss a mail or two, like I missed Veena's mail in between many mails, you can just ask me in the class and I will be happy to explain it just like how I explained now. Okay. This is my mail ID. All the links to the slides and the videos are maintained on my website at this URL. So I will share the links at the end for the videos and the slides. And I hope you've been able to access them as well. Because of the number of people that join, I usually keep the meeting muted, but I'll be monitoring the chat. If anyone wants to unmute and say something, please let me know. Uh, okay, fine. Yeah, please let me know if you want to unmute. I've just disabled mic for everyone. Okay, so there's another question that Veena has. Let me just show everyone. So Veena says that also I had one more theoretical question in Python. When control jumps to the main from a function snippet after giving the function call, do the variables created in the function get stored? Okay, sorry. Get stored in the memory, or do their values get erased? In C++, the values of function specific variables get erased when control jumps from function to main. Is it the same in Python? Okay, this is a little technical. If you don't fully understand this, don't worry about it. But Veena, I will say that the variables inside a function are accessed within that function only. So they are not accessed outside, for example. I think, I know this is the case in C++. I am pretty sure, I'm 99% sure, I'm actually sure that this is the case in Python also. You can just test this by creating a function and trying to call the variable outside the function. I think it will not work. Mostly, I think this is the case. Okay, my mic is off. Why? I don't know. I'm attending regularly and progress also in my attendance. Yeah, I turned everyone's mic off because in the first class there was a huge number of people, like more than 200 or 300, and when one person muted, it was unmuted, it was causing disturbance to the class. So if you have any doubt, you can please unmute, you can request me to unmute and I'll give you mic access, but I'm just keeping it disabled for just the general comfort of the class. Okay, because in the first class people are accidentally unmuting, it was a very big hassle. Okay. uh Attendance, don't worry about it. I have the attendance sheets. It automatically gets logged in Teams anyway, if that's what you're worried about. Okay. Okay, I think we can go to the session now. Again, if you have any doubts, please put it in the chat. And if you want to unmute and say something, let me know. I'll just give you mic access then. But again, okay, fine. So now in this week's lectures, you have seen dictionaries, which are a new type of data container. So we saw the data types before. We saw that there are primitive data types like integer, float, characters, booleans, etc., strings, whatever. And then we saw that there are containers of data types. So lists are containers of data types, where a list is basically an array of integers or strings or whatever it is, right? So we also saw ways to sort and search. And these were the main two topics you learned. Again, two very important topics that you can use in a variety of applications in your computer science. Okay. So I show this slide in every lecture because it is very important that you write not only code, but you write good code. So please make sure you write your code in a meaningful way and you follow some practices and norms so that your code is of a minimum standard. Okay. So, what is a dictionary? As I said, a dictionary is a collection of data. It's like a list where a dictionary is made up of other data, for example. And in dictionary, the main thing is that we store data in key and value pairs. Okay. So, dictionary is ordered, which means that it has a particular order in which it comes. It's changeable, but it does not allow duplicates. So, every key can occur only once, and a key may have multiple values. So for example, here you can see that this is a dictionary which has a key of name, and the value of that key is John. The key age has a value 36. The key country has a value Norway. As of Python 3.7, dictionaries are ordered. In earlier versions of Python, dictionaries were unordered. So just make sure which version of Python you have, and that may cause a difference in how dictionary is implemented in your version. Okay. So let's go to sorting, because this is what I wanted to discuss in some detail. Because sorting is very interesting. It's a very interesting way in which we can look at different ways to do the same thing, right? Because as I said before, computer science and programming in general is a very creative field. It's somewhere where the same question may have multiple answers, and sorting is one example of how that can be done. And whenever we write a program, there are many ways to do it, right? For example, the simple example is when I want to print the numbers from 0 to 100, I can write 100 print statements, right? Or 101 print statements, but I can also use a loop. So, both of these have the same result, but one is a very stupid way to do a very simple problem, right? So, whenever we're writing a program, it's not so obvious which may be the stupid way and which may be the smart way, because the 0 to 100 example is very obvious to us, but some programs may be more subtle than that. So we really have to investigate which would be the best case for our scenario, which program takes the less time. So which is basically programs which take a lot of time are called computationally expensive. And when you have to run a lot of programs for a lot of data, a program which takes say a half a second more is actually really bad, because half a second over a million times of runs is actually a huge amount of time. So we always have to minimize the time over which our program runs and make sure our algorithms are as efficient as possible. Okay, so these are a bunch of sorting algorithms that we have seen in these classes. So let's take a look at them very quickly. Okay, so first of all, you have bubble sort. It's so then, as the name suggests, in this case, what you do is you bubble up the values. Okay, so in every so what happens is you go through the array multiple times. In every pass, you try to find the biggest value. So here, all the examples I'll be showing you are examples of sorting an array into ascending order. I also have the programs for the same, and I'll be sharing it with you. I suggest all of you to do one thing, which is to write the same programs but to sort the array in descending order. It's only a very few minor changes here and there, but I would suggest that instead of just taking the program I'm giving you and just modifying it in a few places, try to understand the algorithm and then apply it to the descending order and try to write it from scratch. So this will really give you an idea of whether you really understand the algorithm or not. So this is a homework that I suggest to all of you, is to take these different sorting algorithms. I've already given you, I'm going to explain to you how the ascending order sort works and I'll give you the programs also. Just try to apply the same funda and get the descending order algorithms as well. Okay, fine. So here you can see that bubble sort. Okay. So in bubble sort, what happens is you start off with an initial unsorted array, and then you keep comparing adjacent pairs of elements, right? So first of all, you will compare the first and second element 5 and 3. You find that they are not in order, so you swap them. Then you compare 5 and 8. You find that they are in order, don't swap them. And you already know how to swap variables by values and variables, by the way. We already learned that in the first class. Anyway, then you compare the next two elements, you find that they are out of order, sort them, swap them. Then again you compare the next two elements, you swap them. So now 8 is in the correct position, right? The biggest element has reached the last position, which is what we want in an ascending order array. We want the biggest element to reach the last position. So this is why it's called bubble sort, because in every, so this is just one pass. Now I have to do the same procedure again for these four elements, then for the three elements, and so on until there are no more swaps which are required. So you keep doing multiple swaps in every case until there are no more swaps required, which basically means that if you go through the full array with no swaps required, it tells you that the array has already been sorted into the uh, right case, right? So this is called bubble sort because at every case, the biggest element here is bubbling to the top, right? You can see that 8 is slowly bubbling to the top. Similarly, in the next pass, you will find that 6 bubbles to the top. Here, actually, 6 is already in the correct position. So you don't need to do any swaps to make it reach there. So this is how bubble sort works. Okay. And I can show you the program also. So here, oh, sorry, this is a different code that I was running. Okay, so here is the Okay, so okay. So here is the program. So you can see that I have a function to bubble sort through the array. This is the length of the array. So we are going to go through all the elements in the array, and we are going to compare the adjacent elements. That's what this is doing. So you can see that if the adjacent elements are out of order, then they are swapped. This is basically swapping. If you don't know how this works, just go check the first lecture. I think first or second class we have looked at swapping. So you can see that I'm passing this array, and this is actually the worst case to pass through bubble sort because this is a completely descending array. So that means that it has to do the maximum swaps if I give a array like this to bubble sort, right? So that's what I'll be doing here. So you can see that the sorted array has come to be the correct array. So this is what is bubble sort. Okay. I hope this is clear to everyone. Sorry, we are here, right? Okay. Any doubts? I think bubble sort is pretty easy. How to apply bubble sort in code? I mean, that's what I just now showed you, right? The bubble sort I showed you in the code. So the use of nested for loop in this case is because we have two loops, right? One is that we have to go through and compare each element like this, right? This is, for this we need a loop because we need to keep comparing the adjacent elements. The other loop is we have to repeat this whole process itself again and again. If we just do this once, at the end, this is not sorted already. We have to again repeat this until no more swaps are required. So that's why we have two loops. One loop is to just take the full array and go over it. The other loop is to compare the adjacent elements. That's why we have a nested for loop. So I already showed you how to apply a for loop bubble sort in the code. Okay. Okay. Any other questions in bubble sort? If not, let's go to the next one. So the next one is called selection sort. At first glance, it will look like we are doing the same thing as bubble sort, but there are a few differences. Okay. So here in bubble sort, what we saw is that whenever we find that two elements are out of order, we immediately swap them, right? That's why it's bubble sort. You keep bubbling up the largest element to the top. So you immediately, so you have a lot of swapping which is being done. In selection sort, what you do is you again compare adjacent elements like this. So what you're actually doing here is you're trying to select what is the smallest element or the largest element, for example. Here it's the smallest element. You can do it in a couple of ways. So you try to select which is the smallest element and then swap only that element. So in bubble sort, we did a swapping every time we encountered something that was out of order. Here we will again be comparing adjacent elements. So again there'll be two loops. One is to do this process over and over again. Other is to compare the adjacent elements. But the point is that we will only swap once. That is, here you can see that we compare and compare until we find the smallest element. Once you find the smallest element, you swap it to the first position. Then again, you have to compare with the remaining elements, which is the next smallest element, which is the next smallest element, and so on. So you select the smallest element in every pass here, and then you put it in the correct position. So unlike bubble sort, you don't do multiple swaps. In every pass, you just do one swap, which is with the smallest element of that array. Okay, is that fine? So I can show you how to do that. So let's do the second sort. So this is selection sort algorithm. So here you can see that I am again having a, I'm checking for, again, I'm nested for loop, right? Because one is to just go through the array. The second one is to actually compare. And here, instead of swapping every time inside the second for loop, which is what I did here I'm actually only swapping once per traversal, because I only want to find out what is the minimum index, right? From the minimum index, I will be doing. Oh, okay, fine. I'll go slower. So, yeah, this is selection sort. I think it's not so difficult to understand. Essentially, in bubble sort, we are comparing, and then the moment you find something is out of order. So, for example, in this example, in bubble sort, what would have happened? The minute it finds that 20 and 12 were out of order, it would have swapped it. Then it would have swapped the next case, etc., until 20 reaches the end, right? Instead of that, what I'm doing is I'm comparing and finding which is the minimum element of the array. Once I find the minimum element, I swap only that element to the first position. Now I take the remaining four numbers, find the minimum element, I do only one swap. So what I'm saying is that in each cycle, I only do one swap. Whereas in bubble sort, in each cycle, I do many swaps, right? So that is the difference between bubble sort and selection sort. In selection sort, I'm actually selecting what is the minimum element. That's why. Okay. I think it's very similar. It's just the swapping is done in a slightly different way. Okay. The final sorting algorithm we have is called an insertion sort. So in insertion sort, what you do is you maintain a sub array and you keep sorting that array and adding elements to it. Okay. So essentially you keep inserting elements to the sub array, and that's how it works. So bubble sort, remember, the largest element is bubbling to the end. Here we are selecting. In the second case, we are selecting what is the minimum element and doing one swap to put it in the correct position. In insertion sort, we are actually maintaining a subarray and then inserting the element in the correct position in the array. So you can see here again, first I just start off with this. In the second pass, I look at where 1 is, right? And then I put 1 before 23. Okay, basically I'm just sorting these two elements. Then I look at 10. 10 I know should come between 1 and 23, so I insert it in that position. Similarly, 5 I know should come between 1 and 10, so I insert it in that position, and so on until I've inserted all the elements in the array into my subarray. So this is how insertion sort works. Okay. So it's very simple again. These are simple algorithms. You will understand them easily. So here again, okay. So outer loop is we have again two loops. One is to maintain one of the smaller arrays, and then the second is to insert elements. So outer loop is to traverse on length of list 1. And then we are moving elements which are greater to one position ahead of their current position. And then just, removing each element at a time. And that's how you get it. So you can see that we are maintaining a list, right? And then in the we basically are just inserting elements here. So you can see that all the elements which are greater, we are moving them to one position ahead so that we can insert the new element into the correct position, right? Because, so for example, here, sorry, Mm, sorry. So here, for example, if I want to insert 10 here, I have to move 23 to a greater position and then I'll insert here. If I want to insert 5 here, all the elements which are greater than 5, so 10 and 23 have to be moved up one space so that we can make space for 5. So essentially what is happening in this code. Okay. So you move everything up by a case and then you insert it at the correct position. So this is the insertion part. Okay. Is this fine? So I'll give you the codes. Please try looking at them. It's easy to understand the funda, but I think to really understand these codes, what you can do is, again, as I said, Don't look at the code which I gave you. My codes are for ascending order sorting, right? Where smallest to biggest you're sorting. Try to rewrite the code for a descending order sort, which means you'll be sorting from biggest to smallest. Okay. So you can try out this in your time, and that will actually give you a feel for the algorithm. Okay. Someone is asking about the pattern of question of the final exam. So, as I mentioned before in these classes, I am an external person who comes to teach you these problems and give you some exposure to the questions. I'm not actually in charge of, anything related to exam or assignment or anything. So, if you have any logistics things like this, please can you please check this with the discussion forum in your course page, because there are dedicated TAs who handle this and they can answer the question better. Time and space complexity. Okay. So, time complexity is basically, I'll tell you in very simple words. I'm not a computer scientist. So, these all have very strict definitions and you can look these up. But the basic idea that to get a feel for it is time complexity is how much time a program takes to run a result, right? So, as I said, if a program takes n amount of time, if a program scales, if the time of a program scales with the length of the number, then it's of order n, for example. So that means that if a 10 digit number is taking 10 seconds, then a 100 digit number will take 100 seconds, for example. Whereas some programs are order of n squared, which means that if a 10 digit number is taking 10 seconds, 100 digit number may be taking 10 into 10, sorry, 100 into, n squared, right? Ten digit program may take 100 seconds, 100 digit program will take 100,000 seconds. So this is how it works. So that means that bigger numbers will get even bigger time. So order n squared is not a very good complexity to have. Order n itself is not very good. So people try to minimize the time, because if you want to run a program for a very big number, then if the complexity grows exponentially with time, it's not very good. Okay. Space is of course similar thing, which is how much space, how much disk space. So I was talking in the beginning about storing variables in memory and all that, right? So you need certain amount of space to run this, and you know this when you run many programs at a time, your computer starts complaining, right? Your RAM gets filled up, right? So everything becomes slower. If you run a very heavy program in your system, your RAM gets filled up, right? So you should try to write programs that don't do that. They don't cause so much pain to your computer. You don't, for example, we have a tendency to store everything, every variable at every step of the way, right? It may not be necessary, because all of these processes take space. For the simple programs that we are discussing in this class, these issues don't matter much. But when you're doing this in a professional setting where you have to run a lot of data or large volume of data, these are the questions that you have to think about. Okay. And also you might be running it on a server which is shared with other people. You might be allotted only certain amount of time. In that case, you have to try to optimize your program so you make the best use of whatever time you have given. Okay. So that is what time and space complexity is. So that's why you can see that there are many different algorithms. So it goes back to the same idea, right? 0 to 100, if I ask you and you write 100 print statements, that's like a very inefficient program. So the way to quantify that is using these complexity factors. Again, these have exact mathematical definitions. I'm not a computer scientist, so I can't tell you those off the top of my head. But I'm sure you can find it anywhere that on the internet or something. But this is the funda for it. Okay, so with that, let's go to the main part. Okay, so we have looked at the sorting algorithms and dictionaries. Let's try to solve a quick questions, and then we can um, then go to the programming part. Okay, so the first question, as usual, please put your answers in the chat. I'll just give me a second. So the question is that which of the following is the correct way to add data with the key of CS102 and value to be database management system to a dictionary named courses. So this is about dictionaries, which we just discussed now. Okay. Okay, I can see people saying C. One person says D. Okay, I think we can go to the answer. This is a simple question. The answer is actually C. So whenever you write a dictionary like this means dictionary of key is equal to value. So this is how you allot a value to a dictionary. Okay. So very good. And D is also correct way to allot a number, but here they have asked us to, the key is given as 102. So that's why this is wrong. Okay. So read the options carefully always, because they try to give you these tricky options to just confuse you. Okay, so this is about the other question, which is about which I didn't do in my recap, but which you discussed this week, is about the Monty Hall problem. So you discussed the Monty Hall problem in your class, right? Yes or no? It's about the probability game show. Yeah, okay, good. So this is a question. What is the probability of, yeah, okay, good, good. So what's the probability of Monty not opening a door with a goat, given the hypothesis that you initially chose the door which has a car? Okay. So I can see two answers. A. Okay, 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 fine. So I can see that there is a clear majority. Most people are saying A. A is the correct answer. It's a very simple question actually, because if we are already given that we have chosen the door which has the car, we know that in the Monty Hall setup there's only one door which has a car, so the other doors should have goats. So there is no probability of Monty not opening a door with a goat. That's why the probability is zero. Basically, it's certain that Monty will open a door with a goat. Okay. Next question is an interesting one. Okay. So, what should be replaced with the question mark? This question mark over here in line 10. Okay. If you can see my cursor. So that there is a high chance that final choice is equal to 2. Okay. This is a multi-select question. So think about the Monty Hall question and answer. So there are two multiple answers in this case which are correct. So this is again related to Monty Hall problem. So read the code carefully, try to understand what the code is doing, and you can understand. Okay, someone says B. Okay, one other person says B. Okay, I can see A, B, and C now. A and B. B and C. Okay. Can anyone explain the logic behind your answer, whatever answer it is? A, B, C, whatever you're answering. Can someone tell me what is the logic here? Why A and C, or A and B, or B and C, or whatever you're choosing? Okay, I can see a lot of guesses, not clear majority, but Seems B is kind of majority, but yeah, if anyone can tell what is the logic behind your answer. We need if true or if false. So which do you need? If true or if false? You can't have both, right? Huh. Right. Okay. So Veena has explained it. Correct. Correct. Okay. Good. So we'll go to the answer. The law. Okay. No, Veena, it was A and C. You are right. So don't doubt yourself. So the answer is A and C. So the understanding here is again, this is a little easier to understand if you have already seen the Monty Hall problem, which was discussed. So here you can see that we have goat, and car. As you see, these are the three doors, and we ensure that Monty is opening the door which does not have a car, right? So whatever is the goat, right? So we want to make sure that the final choice is 2, because 0, 1, 2 is only having the car. So we want to, like this real problem says, we want to make sure that the maximum probability is that we get the car. And what the Monty Hall problem tells us is that it's always good that if Monty doesn't open a car, then we have to swap it, right? Swapping gives you a better probability. The mathematics I am not discussing now, that is in your lectures, please go and watch it. So the point is that this is the code to actually swap. Okay, so this is so that Monty chooses a goat, and here is the swapping code. So if you want to go into this if we want to actually go into this if, then we actually always want to swap, because again the Monty Hall problem tells us that swapping always gives us a better probability. So that means we just need this if to be true always, right? So we need to choose a statement among these four that is always true. So something that is always true is going to give us this. If you give just a number to if, that is always going to be true. Okay, so if you give 0, that means false. If you give anything other than 0, that Python reads as a true condition. So if you just give if 2, then that reads as a true condition. Again, the other thing is we have to check which of these other statements evaluates to a true number. So first of all, here it's telling me that 2 to the power of some number, which I don't need to care what it is. Mod 2, this gives me the reminder, is not equal to 0. I know this is false, right? 2 to the power of 1024 is basically going to be some even number. That is definitely going to give 0. This is false. Similarly, here this is also going to be false. You can check it out. And this is obviously a true condition. This is again some even number mod 2, which is obviously going to be 0. So both of these are the correct option. You are under no compulsion to attend these classes or have attendance in these classes. Don't worry about it. That's why these sessions are recorded, so you can please go. Okay, that's fine, that's fine. You got the funda right, so don't worry about it. You got the reasoning correct. Yeah, please don't, you don't under no compulsion to attend. If you are having some sickness or something, the recorded sessions are available. Slides are also shared with you, so you can see it at your leisure. Okay, the attendance is automatically marked by Python. I'm not marking any attendance, so don't worry about it. Okay. Sorry, not Python. A Python course, I said Python. The attendance is automatically marked by Teams, so don't worry about it. Okay. Fine. So let's go to the next question. I hope everyone understood this question. So basically, I need to always swap. That's what Monty Hall problem taught me. For that, I need a true condition. If you check these two are only the true conditions in the set. Okay. Fine. Next question is about binary search, which again I didn't discuss, but it was discussed in your lectures. So given that you have a sorted list of 2048 elements, what is the maximum number of comparisons to search such an element using linear search? Can binary search do it in a less number of comparisons? So again, comparing two elements, and you have to search for an element, right? So uh, here you have a sorted list. Please answer in the chat which is the correct one. Okay. 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 Can see that many people are answering B. The answer is B, correct. Binary search is more efficient where you just divide the array into 2, 2, 2 and do it. Linear search, you're actually just going through every element and doing it, and it may be maybe the element is at the very end, in which case you have to compare all 2048 elements. So good, all of you got that very correct. Okay, what is the use of a file with the dot WAV or WAVE extension? Okay, B, C, D. Okay, it seems to be between D and C. This is only one. There's only one option which is correct here. Okay, I think I see all the options at some point. Okay, maybe we can go to the answer. The answer is actually D. I don't know what waves of files means, but that's not it. .wav is a audio format, just like MP3. So you can always convert a .wav file into a MP3 or something like that. Okay, so that's what it is. Okay, next question. What does this program print in the end? So this is the program which is given here. What does it finally print? So go through the program carefully. Okay, someone says A. Someone else also says A. Okay, A. More A's. Okay, good. I think most people are agreeing. The answer is actually A. To understand why, just look at the condition where the what is finally being printed is the counter by n. N is the total number of throws with some fraction. And when does the counter actually increase? When the two choices are not equal. So it gives us the fraction of throws where both the players showed a different symbol. Okay. Okay, next question. This is a simple question. You should immediately answer. In binary search, a list gets divided in every iteration to find the element, correct or wrong, true or false, sorry. Okay, okay, okay. Okay, good. Immediately I can see answers. True, A. I think we can just go to the answer. Yeah, true. So that's why it's called binary search because every time you actually divide the list into half and then search in that half list or whatever it is, right? Okay. Which of the following are requirements for binary search to work correctly? Okay, I can see C and D. C. Okay, I think we can go to the answer. The answer is actually C. So duplicate values is not an issue. The only thing is that the search will just give you the first one of the instances of that value. It will not give you all the instances, right? If you want to go into all the instances, then you have to write the code in a different way. But binary search can return the position of at least one instant of a duplicate value. So duplicate value does not affect it, but sorted definitely. Then only we have this funda of dividing the list in the first place, right? If it's not sorted, we cannot say that it belongs to this half or that half. So that's why. Okay. Next question, given the array 4, 2, 7, 1, 3, what is the array after the third pass of bubble sort? So remember what I told you about bubble sort. Okay, someone says C. A. Okay, I think majority is C, or I can see all the options. Maybe let's go to the answer. So the answer is C. So again, just think of it this way, that after bubble sort, always the largest element will have bubble to the top. So you can think that 7, 4, 3 are definitely going to be in the correct position. The question is whether 1 and 2 will be in the correct position. So with that, we nearly need to work this out. So let's try doing one together. So in the first pass, let's see. So what will it first? It will compare 4 and 2. Then it will swap them, right? 2 comma 4. Then 4 and 7 it will not swap. Then 7 and 1 it will swap. So now it's 2 comma 4 comma 7 comma 1 comma 3, right? So like that, if you work out each of them, you will find that in the third by the time third iteration has come, 1 and 2 has also been swapped, because 2 will be compared with 1, because 1 would have come here, right? Already 4 and 7 have gone, so 2 and 1 would have come. So in the third pass, actually 2 and 1 will also get swapped. Okay, so I'm not just I it'll take a long time if I write out all the iterations, but if you understand how bubble sort works, just try writing it down and you will find that C is the correct option. Okay, is that fine? Yeah, so that's true. Before all the passes, the sorting takes place. So that's why bubble sort is not very efficient. Okay. So one thing you can do is you can put a option in the sort that if you don't do any swaps, then that means that this array is already sorted, right? For example, as you said very correctly, if I do a fourth and fifth iteration, it's not going to do any swaps. So I just you can do what you can do to modify bubble sort is you can put a counter on the number of swaps, and if you go through any full pass without any swaps, if the swaps remain zero, then that means that the array is already sorted, right? So that's one change you can make to make it a little more efficient, so that you don't do these unnecessary passes, right? So this is how you have to think to make your program more efficient. The other thing is that, yeah, even in that case, it will still go through the array at least once to make sure that the sorting is actually done or not. So in that sense, it is, it's always going to have at least one extra traversing to just check for the number of swaps it has. Okay. Yeah, bubble sort is the most primitive algorithm. It's not the most efficient. There are more efficient algorithms in the market. Okay, so how many swaps are performed in iteration 3 for bubble sorting the list of 5, 4, 3, 2, 1? Answer 0 if the list is sorted in less than 3 iterations. Okay. So I'll give you some time to work it out. I would suggest trying to write this down with a pen and paper. The question is that how many swaps, which means swaps are done in the third iteration. So you each time in bubble sort you traverse through the whole array, right? In the first iteration, the biggest element bubbles to the top. The second iteration, the second biggest element goes to the top. Third iteration, third biggest element, and so on. So how many swaps are done in the third iteration? That's the question. Okay. So someone says three, someone says two. Any other answers? Okay, let's go to the answer. It seems that people are between 2 and 3. The answer is actually 2. Okay, so again, I would recommend writing this down in a paper and trying to see it, but let's try to quickly see it. In the first iteration, 4 and 5 are swapped, and then 5 and 3 is swapped, and then 5 and 2 is swapped, etc. So it will be like 4, 3, 2, 1, and 5, right? In the second iteration, 4 and 3 are swapped, 3 and 4 2 4 and 2 are swapped, etc. So it will become 3 2 1 5 4. Okay, sorry, 3 2 1 4 5. Okay, so in the third iteration now, so third iteration beginning the array is 3 2 1 4 5. So 3 and 2 has to be swapped, and then 3 and 1 has to be swapped. So two swaps are done. Okay, 3 and 2, 3 and 1. So that's why the answer is 2. There are three numbers, but there are two swaps. Okay, that's the idea. Is this clear? Again, if this is not clear to you, you can do two things. Either you can write it down or just write a bubble sort program and write down all the swaps. I mean, you can just print out the swaps and you'll be able to actually see iteration 1, this many swaps. Iteration 2, you can actually put a counter on the swaps and you can check this yourself. It's a fun project to do. Okay. Okay, I think this is easy to understand. I mean, if you don't see it immediately, again, I would highly encourage you to write this down and try to see it. But it's just that it will be 3, 2, 1, 4, 5. So 3 and 2 has to be swapped. And then after 3 and 2 swap, 3 and 1 has to be swapped. That's why there are two swaps. Okay, fine. So let's now go to the programming assignment part. So again, I'll give you time to work out the program and then let's discuss the solution. So I'll give you some time. Again, if we don't discuss all the programs that I have planned, it's fine. I always share all the questions and programs with you in the Google Drive. I hope you've been able to access them. The main purpose of this 1 hour, which is remaining of your class, is now so that you get some time to actually try to write programs or at least get the programming logic right on yourself without relying on a solution. Okay, so even when you after the class, if you get the solution, don't look at it immediately. Try to do it yourself and give it an honest effort. That is really how you will learn programming. Okay, so this is the first question. Write a function insert, okay, that accepts a sorted list L of integers and an integer x as input. The function should return a sorted list with the element x inserted at the right place in the input list. The original list should not be disturbed in the process. Okay, you're not allowed to use any built-in methods other than append and remove, and you don't have to accept input. Okay, so here very important here is we need a sorted list. Okay, we are taking in a sorted list as input and you will be inserting an element to the correct position in that list. So suppose you have a list like 1 2 4 5, then I want to insert 3 into that list, so it should give me back 1 2 3 4 5. That is the idea. Okay, so I'll give you 10 minutes to work out this. Please, all of you try it out and let me know if you get the solution. Just run it for a case. You don't have to share the code in the chat necessarily. Just you can itself put this example of 1, 2, 4, 5 and 3 and check if 1, 2, 3, 4, 5 is your output. And that way you can check if your program works. Okay, I'll give you some time. Again, even if you don't get the answer, it's fine. But at least try to get the logic. Okay, I'll give you some time. Yeah, just try out this program. I'm just giving a few minutes to everyone to try out the program. Please try to write the whatever the program says. Okay. Okay. So, how many of you are trying? Can you just raise your hand? Okay, good, 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 good. All of you, please try. As I said, programming is only useful, these classes are only useful if you try to do programming yourself. Done? Okay, good. So did you can just check your code with your the example I said. Others, if others you are done, any others who have got, I'll give like 2 more minutes and then maybe we can discuss the solution together. Hmm. Okay, someone has given their answer in the chat. Okay, but this is this giving the correct answer? Let's see. Sorry, I don't code in terminal, but for quick looks, it's fine. Okay. Mm. Okay. Okay, you know what? I'm just gonna take your word for. I just put it in VSC. I don't know why I'm doing so much. Sorry guys, it's been a long day. Let's see. New file, Python file. Okay, your code S5 replace. Okay, good, it works. So I was just worried that x less than n, it will just do it at the first position that it is there. But no, it's because it's looping through, it's fine. Okay, good. It works. Great. So let's go to the answer now. I was just curious about if that program worked. So again, lots of ways to do a program. Okay, so as long as you're clear with the logic, it's fine. Okay, so here is the program that I wrote. Okay, let me just explain it first and then we can run it. Okay. So this is output. So insert, we take list and whatever is the element as input. This is output list. Here I'm just having a flag to say that if that list element has been inserted or not. Okay. Ignore this for now. If you put, you can also have not inserted to be true and then set that to false. So again, creativity, right? Okay. So now for any element in L, so every element, so I'm traversing through the list. If inserted is actually false and the element is greater than x, then just append it after the output list and inserted is true, right? So then you append the rest of the elements essentially. Okay, so you just append it just before this position except. And then if you don't insert at all during this whole process, that means that the element is bigger than all of the elements, right? All the other elements in the list. So suppose I had given you 1, 2, 3, 4 and I asked you to insert 5, then 5 has to be appended at the end of the list. It's not smaller than any of the elements in the list, right? So you have to put this extra condition that if throughout this process inserted remains false, that just tells me that x is bigger than all the other elements, so it has to be appended at the end. So I can just show you the result. So if I enter the list now 1, 2, 3, 5, enter x to be 4, then 1, 2, 3, 4, 5 is the answer. Okay. Is this clear to everyone? I've done it without function, that's fine. Can we append x first then use bubble sort? Sure, but you're already being given a sorted list, right? So if you're, it's kind of like if you can do that, that is completely fine. But you're already given a sorted list. So the reason you're given a sorted list is so that you don't have to do a sorting at the end again. Okay. But yeah, of course that works. I append it to the end of the list and applied bubble sort. That's fine. But again, you should try to use the fact that you have a sorted list, right? That helps you a little bit. But of course, again, if you're getting it in a whatever way it is, if the answer is correct, that's fine. Good, very good. So already we've seen like couple of ways to do the same problem. This is exactly what I want from these sessions, and that's why I don't discuss my solution first because everyone has a different way of doing the problem, right? Which I may not have thought about. So I didn't think about this bubble sort thing. So that's why it's important to try it yourself so you have your spin on the problem. Let's go to the next question. Okay, mystery of word frequencies. So you're tasked with sorry analyzing a mysterious message that was intercepted. The message seems to contain series of repeated words, and the challenge is to count how many times each word appears. To solve this, you must write a Python program that takes a string of text and counts the frequency of each word. Make sure your program is case insensitive, as a secret message is a mix of upper and lowercase letters. So this just means that if I write dog in full capital letters or dog in small letters, it is considered to be the same word. Okay. We don't care about case here. So that's why it's case insensitive. After counting the occurrences of each word, display the results. Okay. So this is a question. I hope it's clear to everyone. I'll again give you 10, 15, whatever, 10 minutes or so. Try to write the program and let's discuss it after that. Okay. So all of you can try first. Yes, converting word into one case is a good way to do this because, as they say, case insensitive. So if you first convert the whole string, that's a good way to do it. Yes. So I hope you guys are trying. Please try and let me know. Can we use the collection class? I don't know what that is. What's collection class? I'm not sure what that is. But yeah, sure, if that works. Because each word is separated by space. Yes, because this is a sentence, right? So it is a sentence. So in a sentence, words are separated by spaces. Yes. Oh, okay. Don't just use a counter. Try to write your own program. But sure, yeah, if you can do it that way. Try to do it in your own way. But this works. Yeah, sure. I didn't know about this function. You have to just write the program. So, did you understand the program? The program is basically you have to, if you have a sentence, for example, the cat drank the milk, then, for example, the appears twice, cat appears once, drank appears once, milk appears once, right? So, you will have a counter at the end saying the two, cat one, etc. So, you have to write a program that does this. Yes, okay, good. So people are sharing solutions. First, you split to get a list, correct? Then use dictionary to get number of occurrences of each word. So how do you do that? You just figure it out. So yeah, I think we can maybe discuss a solution since people are already discussing some solutions in the thing. Unless people are still working out and want some more time. All right, let's look at the solution. If you're still working it out, you can continue. I'll just discuss the solution because some people are already discussing it. Okay, so let's go to okay. So here I'm taking a function which is taking a string as argument, right? And I'm taking a dictionary, okay, that has counts. So store the word frequencies. I'm splitting the input string because again I'm assuming that spaces are the separators because it's a sentence. So you're going to iterate through all the word in the words list and then check if the word is already in counts. That means it's a key. Okay, I'm just checking if so I'm here in my dictionary. Remember, a dictionary has key and values, right? So here my keys are going to be each of the words in the dictionary, and the values are going to be how many times they occur. So if the word is already in the dictionary, that means you just increase its frequency by 1. If the word is not in the dictionary, I'm going to add it to the dictionary with a frequency of 1. Then you're going to return the counts dictionary. That's all. So it's a very simple program. So again, you don't need to import any functions because it's just a simple function. Probably the functions you import are doing the same thing. Okay, so let's do this once again. Okay, clear. Let me just clear it and run it again now. Okay, so let's give the sentence I gave. Okay, so immediately you can see the mistake I made. I didn't convert the string to one case. So you can see that the and the were counted as different words, right? So let's first just, how do you do this? str.lower. Yes. Yeah, okay. I think this is one. Okay. So now, yeah. So now you can see that the is counted twice, cat is counted once, drank is counted once, milk is counted once. So I forgot to convert the string to upper or lower case. So in the first case, it actually counted THE with capital T and THE with small t as two different words. So this is not what we want. Okay. So this is to ensure case insensitive, which was given in the question. Okay. So the simple program. Does everyone understand the program? Any doubts? Any doubts in this program? So again, this is a simple program. It was very easy because of the dictionary, because dictionary always pairs up things. So we are able to create a key value pair for each word and its frequency. Okay. Okay, good. Let's go to the next question. Next question is also very simple. Try writing the program itself. Write a Python script to generate and print a dictionary that contains numbers between 1 and n in the form of x comma x squared. Okay. Accept n as the user input. Yeah, you can do it in however way you want. But again, the try to use less user already defined functions and try to write your programs at least when you're starting off learning programming so that you have an idea of what's going on. Later you can use all these specialized functions which you're talking about. Yeah, if the string is given lowercase, then it will not make any difference to that case because it's already in lowercase. So that is okay. So again, we have to keep it as general as possible because the user may input anything, right? No, you solve the assignment yourself. I would say that unless you have some specific question in the assignment, I would highly recommend you solve the assignment yourself. That's why the course is there. If you have some specific pointed question, you can mail me. I can try to help you, but I would highly recommend you try it yourself. Okay, good. So, are you guys working on this? Okay, good. Someone has given an answer. Any other answers? Okay. Another another answer has been given. Very good. I'll give a minute or two in case people are still working on it. Okay, okay, fine. Cool. So you guys are giving your solutions. So I think we can go to the solution. Yeah, this is quite a simple program. I think you would have all got it. So let's go to the program. I'm just entering a number. I'm putting an empty dictionary. So this is one way to initialize an empty dictionary. Another way, which I think one of your friends did, is to just put two curly braces like this. That also initializes an empty dictionary. Like how to initialize an empty list, we put two square brackets. For initializing an empty dictionary, we put two curly brackets. Okay. Then in for x in the range 1 to n plus 1. So why n plus 1? Because remember range will always not count the last number. So I want to include n. That's why it's 1 to n plus 1. Calculate the square of each number and store it in the dictionary with the number as the key. So dictionary of x is equal to x squared, and I'm printing the number. So if I just input say example 5, you can see that 1, 2, 4, 3 square is 9, 4 square is 16, 5 square is 25. Okay. So I think this is a simple program. I don't think there are any doubts in this. Let's go to the next program. Okay, next question. Merging dictionaries. So you're required to write a Python function called merge dicts. Sorry, that takes two dictionary as input and returns a new dictionary containing all the entries from both the input dictionaries. The function should not modify the input dictionaries. The dictionaries will have strings as keys, as numbers as values. In the case where the same key appears in both the dictionaries, the corresponding value in the output dictionary should be the sum of the value from both the dictionaries. Okay? You need to ensure the following. If a key exists in only one of the dictionaries, its value should remain the same. If a key exists in both the dictionaries, sum the values associated. The output dictionary should include all the keys from both the input dictionaries with updated values as described above. So write this program. There are some related way of merging two dictionaries here. You can look at it in your spare time. Here, this is slightly different. Here, you're asked to sum the keys. Here, that is not the case. So that's why I have mentioned this is related, but it's different. So here you can see a few more programs on merging two dictionaries. In any case, now you can try doing this program. I'll give you some time to figure it out. Okay. I hope the question is clear to everyone. So if you have a dictionary like A1 and then B2, and then you're trying to merge with another dictionary that has A3, C4 or something, then because both the dictionary has a key A, the values associated with the key has to be summed up. So you'll get 1 plus 3 is 4, for example, like that. Just, I hope the question is clear to everybody, and you guys are trying it out. Okay, let me know if you have any questions. I'll give you some time to solve it. Let's say 10 minutes or so. I hope you guys are trying it out. And I hope any all of you are trying. Okay, someone has shared an answer in the chat. Good. Others also please try the same. I'll give like a couple more minutes and then I'll discuss the solution. Okay, maybe we can go to the solution. So, okay, so here basically you can see that creating a new function, you just create a copy of the original sorry dictionary. You create a copy because they asked you not to modify the original. I think your friend has also done this. So then with the first dictionary, you are going to compare whatever is in the second dictionary, right? So items means it will just go through all the items in the dictionary, and if the key is already present in the merge dictionary, then just add the value to it. Otherwise, just add the new key and the value to the new dictionary, right? So this is just to enter the dictionaries and then print the merge dictionary. So let's try it out. So let's put three entries in the first dictionary. So A, the value should be 3. Let's put B with value 5 and C with value 6. Okay. Let's put two entries for the second dictionary. Let's put A again here, but with value 1. And let's put another completely different thing, F with value 9. Okay. So now you can see that in the merged dictionary, A is having a value of 4 because in the first dictionary it has value 3 and second dictionary it has value 1. 3 plus 1 is 4. And then all the others are as it is. Okay. So this is why we get a merged dictionary. Okay. So this part, this huge code is just for entering the dictionary values. And this is actually the function. Okay. This is clear. I think this is a simple question. Any doubts here in this question? Okay. If not, let's go to the. Actually, this is good. This week we have been able to do all the questions that I'd planned. So let's go to the last question. This is a very long question, but it's a simple question as you will see. Okay. So you are an apprentice in the Royal Library of the Vijayanagara Empire, homes to centuries old ancient manuscripts filled with the knowledge of astronomy, Ayurveda, and warfare. However, strong monsoon has scattered the manuscript in a raw and random order. The Rajguru assigns you a crucial task to sort the manuscripts using bubble sort. Okay, but you must record the order of the manuscripts after every pass. Okay, so basically, you have to do a bubble sort but display the result at every pass. That's what the question is, but it's written in a nice way. Okay. And the thing is that if there are no swaps, you can stop the process of arranging. So you swap two manuscripts at the time, ensuring the heaviest one settles at the bottom. So obviously these are going to be integers that you'll be sorting. And put this condition in that there are no swaps, you can put the stop the process of arranging. Okay, so I think you all know how to do this question, but I'll give you some time to figure it out anyway. Right? I know you all have the bubble sort program already, so you can just use that, try to do that, and give a print statement for that. Okay. So I'll give you like five. I don't think this will take much time since I think you guys have bubble sort program already. You can try it out. Okay. Does anyone have the answer? Are you all trying? Mm-hmm. Have you all tried the question? Any answers? Okay, I'll give you a few more minutes and then we can discuss the solution. Okay, let's go to the solution. This is the last question I had to discuss, so maybe we can end a little early today. So this is a bubble sort program. Again, it's a very long question, but if you read it, I'm so sorry. If you read it, what you'll see is that they are really asking you to do a bubble sort and then stop the bubble sort if there are no swaps. So let's go to the solution. Program 5. So I think I didn't put the, I'm just now realizing that I didn't put the condition for no swaps. So let's just put that in now. Okay. So here also the other thing is they've asked you to, you must record the order of the manuscripts after every pass. So you should print the array at every pass basically. So that's what I've done here, but I forgot to put the swaps. So let's put the swaps in. Okay. So that means swap 0 swaps equal to 0. Yeah. And in here there should be a swap plus 1. And then if swap so outside the loop, if swap equal to 0, then break. Right? So this basically means that every time every new pass, you count the number of swaps. Okay, you're resetting it to 0 at every time. Every time you go through the array, every new pass. And then if in any pass the swap remains 0, that means it's not doing any swaps, then break out of the loop because that means that there is already the array is sorted and that's the thing. Okay, fine. So go let's print it. So let's go like 11 5 4 5 6 uh 2 1 13 89 something like that. Okay. Oh no, what's up? Oh, separated by space, not comma. My bad. Let's run it again. Okay. So here is the list. So you can see that when it was already sorted, it stopped instead of going through more iterations. So that's why it stopped, right? Swaps became zero. Otherwise, it should have gone through 1, 2, 3, 4, 5, 6, 7, 8 iterations. But since the list already got sorted by this case, it had stopped. So that's why that swaps function is important. So someone was asking before that if the list already gets sorted before the number of iterations is over, then rest of the iterations are for nothing, right? So we can actually see this if I just comment out all these lines which had this. Okay, if I just comment out this, sorry, if I just comment out this condition and let's enter the same list, then you can see that it's actually sorted here itself. It just goes through the list 5 more times because we didn't put that swapping condition. So actually, 5 wasted iterations, right? That's why this is important. That's why this condition is important. Okay. Is this clear to everyone? Clear to everybody? Any doubts in this? Okay, good. So this time we have actually finished all our questions. That's very good. Usually we have a few remaining. So then let me just end by the usual way. So again, these sessions are held for clearing your doubts. So please mail me through the week if you have anything to discuss. Oh, you want to see the code here. Here is the code. Here's the main part. The rest is input. So as I was saying, please feel free to mail me throughout the week if you have something specific to discuss or something like today who had the issue about the code. So just send me a mail. If I miss the mail or if it goes to my spam folder or something I might not have replied, or if I might just miss it because I get a lot of mails every day. In that case, like the person did today, just bring it up in the class and we can just have a free discussion. So these sessions, I make slides and prepare questions, of course, but they are meant for you. So if you want to change the agenda and bring in something new, that's fine. I might not have the answer immediately, but we can work it out together. Okay. And if you send me the question in advance, I can also put it in the slides. Apart from that, all the slides, programs, videos, everything is available to you. And I maintain a page on my website with the links. So I will just share the links in the chat now. What will happen if we assign swap with 0 in this J loop, right? Okay, let's see what happens. If I put swap here, right? Let's think of what is happening, right? In J, I'm comparing every element, right? So let's see what happens. First, let's just run this and I'll show you what happens. Sorry, sorry. You can see that it doesn't even sort the array. It stops here. So why is that? Because I'm just undoing the number of swap counting I'm doing by setting it to 0 within the loop. I actually want to count how many swaps are there. If I'm just going to set it to 0, what's the use, right? So that's why it has to be in the other loop. Because what am I counting? I'm counting the number of swaps in each pass. So it actually has to be outside the loop. Okay. So now if I put it, now you can see that it actually works. Okay. Got it? Okay, good. So I'll just share my links again. Again, please feel free to mail me. And if I don't see your mail, you can just bring it up in the class and we can discuss like I discussed today. And I will also share my website. In my website, you will find the meeting link, the link to the Google Drive where all the programs and slides are uploaded. You'll also find a link to the YouTube playlist where I upload the recorded videos. So you can find all of this in one place. I think apart from that, the NPTEL team also shares the links with you, but I just keep this handy for easy reference. So you can just save this or the Google Sheet or whatever it is. Okay. Okay, fine, good. So I don't have anything else. So unless anyone else has any other agenda, we can end for today. Any other questions or comments? If not, let's end for the day. Have a nice rest of the week. Okay, wait, there's a question. For binary search, maximum number of times comparison array mid equal target for n elements. Is it order of log n plus 1 for the worst case? I cannot tell you immediately off the top of my head. You can probably search this. I think it goes as log n. I'm not very sure though. I'm not going to say yes or no because I'm not very sure. I think that sounds correct. But yeah, as I said, I don't know this off the top of my head. I'll have to look it up. Okay, I can check this and get back to you maybe. If there is no element. Okay. Yeah, worst case is if there is no element, correct, or if the element is at the end or something like that. Yeah, I'm not sure about the complexity in this case. I don't know immediately. Okay. Yeah, I'll check it and get back to you, or maybe you can itself search it. I'm sure the answer is available readily. Ma'am, can you unmute me for a second? I had doubt in the assignment question, but the submission date hasn't ended yet. Then don't ask the question. I'm not going to help you with assignment questions before the date is done. That is very strictly my rule. Okay. I'm not, please don't send me your assignment questions and programming assignment questions. I will not help you with them. Okay. Those are for you to figure out. And if you have any doubt in the submission or something, just ask the thing. Okay. Fine. So let's end the session for today. It was theoretical, I figured out. Okay, okay, fine, fine. Maybe you can just mail me. Let's not keep the others waiting. Let's just end the session. Okay? You can mail me. I'll get back to you. Is that fine? I also had a long day. Okay, fine. Okay, good. Let's end the session then. Have a nice rest of the week. Thanks everyone for joining. See you next week at the same time. Okay? Bye.